Anytime we want increasing, decreasing, max, and min, we go with the first derivative test. So today we're going to talk about the second extrema, which we mentioned yesterday, which is an absolute extrema. Okay? And I'm just going to kind of highlight here. We said the greatest value of a function is called the absolute max, and the least value of the function is called the absolute min. So if we look at this graph we have here, the absolute max is the highest point it ever reaches, and the absolute min is the lowest point it ever reaches. And then these other mins and maxes that appear are called relative. So that's what we've been working on for those past 2 days there, relative maxes and mins. Okay. Important note, both types of extrema are important in calculus. Since both are extrema, we might expect the process to find them to have some similarities. But it's important to note that generally we cannot use the first derivative test to find absolute extrema. Okay, so again, we're not using the first derivative test when we talk about absolute. It says, do you think every function has an absolute min or max value? For each statement, sketch a graph that satisfies the condition below. So in example 1 here, it says the function attains a global min, but not a global max. So global, again, is synonymous with the word absolute. I've really never seen them use global. There's like a few textbooks, but I don't believe our AP ever uses it. It's going to say absolute. We want to draw something that has a global or absolute min, but not an absolute max. So I'm going to make an axis from 0 to 5 here. Now this is kind of weird to think about. I want an absolute min. I want it to go low, but I never want it to have a max, which means I never want it to stop. If I don't have a max, then it's going up forever. So something like it has a min, and then it's going to go up forever. So maybe I'll put an asymptote next to it or something. Okay, so this has an absolute min, but it does not have an absolute max. The function g of x contains an absolute max, but not an absolute min. So I'm going -4 to 2. I have an absolute max, so I have a highest point, but I don't have a lowest point, which again tells me, I'm just going to draw something, you can draw whatever you want there, but it's going to go down forever. Okay, it doesn't have a minimum value. The third one says the function h of x contains a minimum at 2 different x values, but only one max. All right, so I'm going from 1 to 8. I'm going to call that 8. Well, I'm going to call that 1. All right, so I have to have 2 different mins, but only one max. So maybe something like it's going to go down, then it's going to come up to create a max, but now it has to have 2 different mins, so maybe something like that. I have 2 different minimum values and only one maximum value. And the last one says the function k of x is continuous, so I can draw it without picking up my pen, but does not have a min or a max value. Can you draw a function that doesn't have a continuous function that doesn't have a min or a max value? What does your gut want to say it might look like? Oh. That just kind of went against everything I'm thinking, Fran. Oh. That's a great counterexample. It's a continuous function. Goes up forever, down forever. Well, it doesn't go down forever. Technically tapers off like near 0.
Okay. But does it technically like never reach it?
But it doesn't reach it. Fran, you're throwing off my train of thought here because my answer was no. All right, to be determined. I'm going to think a little more about that one. My answer was going to be no, I can't draw a continuous function that doesn't have a min and max. And well, here's the one I was thinking that a lot of kids like to think of. Geez, Fran, you really messed with my head this morning. If I draw y equals 5, let me just think about this. Does this have a maximum height? What's the highest the graph goes? 5. So even this has a max, and its min also happens to be 5. But why would the exponential? I got to think about this for a minute. I'm coming back to the exponential function. All right, flip the page now that I'm flustered. I gotta think about that one. Because that goes with this theorem here. Oh, here's the definition. Never mind. That's why. That's why.
There you go.
Oh, okay. So if it's, okay, we can answer this question, Fran. If the function was not defined on a certain domain, but because they're saying strictly from 0 to 4, that throws off my whole exponential function, because on that little root, it is defined and has a min and a max. So I'm going to go back to my answer and say no, it's not possible, again, because of that closed interval. But that was a great brain workout for a minute. Okay, so here is the last theorem that we have to know, the extreme value theorem. It says if f of x is continuous, and here's the catch to our rule here, on the closed interval, then f has to have both an absolute max and an absolute min. Okay, and you'll see this pop up in, remember how we did those multiple choice questions that were a little sneaky with the tables a few days ago? There was a bunch of them we didn't get to. We said we're going to come back. You'll see a lot of extreme value theorem questions in here. So if your function's continuous on the closed, you have to have a max and a min. Every theorem has conditions. We can only apply the theorem if these conditions are met. If the conditions are not met, then we cannot apply the theorem, of course. What are the conditions for the EVT? Again, it has to be continuous on the closed interval. Okay. Remember, we're just calling this an existence theorem. We're just saying something exists. It's not necessarily we know where it is. We're just saying it exists. And it says the other two existence theorems that we've learned are the IVT and MVT. And these are the only 3 theorems we have. So you've got them all. We just have to get them down by May 13th or whatever day the exam is. Okay, so here's what we do for an absolute extrema. It's different from our other relative extrema. So step 1, we're going to find the critical points. That part's the same. And then everything after that's different. We're going to create a table of values that include critical points and endpoints. Okay, this is not a sign chart. This is a table of values. When finding the absolute extrema, you're going to plug x values into the original function. The greatest value is called the max. The least value is called the absolute min. Okay, and here's the wording that you're going to use every time, and I'm just going to highlight it when you answer the question. The absolute max is whatever at x equals blank. The absolute min is whatever at x equals blank, and we just use that same phrase each and every time. Okay, now again, this is only for absolutes, slightly different than the relative extrema. I'm going to use, well, we'll go through one of these examples here. Well, let's look at this first picture. Is this function continuous on the closed interval? Should be a nice, easy yes. Therefore, because it's continuous on the closed, the extreme value theorem can be applied. Does f of x have a min and a max? Of course it does, because it's a closed interval. And the statement for the absolute extrema. So the absolute highest value, what's our absolute highest value? The value, though, the height is 3. The absolute max is 3, so this is how we're going to write them up, at x equals -1. Okay, so you want to say the value of it. The absolute min is what value? Close. The lowest it goes, -1. The value is -1, and then it happens at x equals -3. Second graph, is this function continuous on a closed interval? No, the interval is open. Can the EVT be applied then? No, it has to be continuous on the closed. Does f have a min and a max? It definitely has a relative min right there. So I'm going to say yes. And I don't have an absolute max because these are open, but I do have an absolute min. My absolute min has a value of -1, so is -1, and that happens at, I'm sorry, the absolute min is -3. Now I'm messing up. At x equals -1. Absolute min is -3 at x equals -1. All right, last one. Is our function continuous over a closed interval? Yes. So the EVT can be applied as long as you're continuous over a closed, and the EVT just says every function has a max and a min over a closed interval. So yes, we have a max and a min. So I'm going to say the absolute max is, so again, I'm looking for the value of the highest point. I would say is 4. And it happens at x equals 3. Also at -3, it has the same value. And the absolute min is 1, and it happens at x equals 1. Okay. All right, so now we're going to go through and just apply it in these questions. So it says find the absolute extrema. So if we kind of look back to those directions, you're going to find the critical points, and then we're going to create a table. So critical points, again, we're going to set that derivative equal to 0. So we'll take the derivative, nice and easy there, 4x minus 8. So now I want to set my derivative equal to 0. We should get x equals 2. Okay, so here's the table of values it says. We are literally making like an x and y table. So this is x and f of x. Okay. I'm just going to flip back for a second. It says you're going to put critical points and endpoints. So I'm going to start with the endpoints. I have to go from a 0 to a 3, and then I'm only going to put the critical points that fall between there. So if I had a number that doesn't fall in there, we're throwing it away. So 2 falls between there, we're going to use it. Okay. Now the odd part is it goes back to the actual function, not the derivative. We are going back to the original function. And we're just going to plug these in. I think we can do 0 in our head real quickly. 0 squared minus 8 times 0 plus 1 is just 1. And then we're going to plug in 2. So 2 squared minus 8 times 2 plus 1. 2 times 2 is 4 times 2 is 8 minus 16 is -8 plus 1. I think that's -7. And then 2 times 3 squared minus 8 times 3 plus 1. 3 squared is 9 times 2 is 18 minus 24 plus 1. -6 plus 1. I think I get -5. Okay, so I'm finding the critical points, making a table, plugging into the original. Now make sure you answer the question. So based off my values, what is the absolute maximum value? Yes, the absolute max is 1, and it happens at x equals 0. The absolute min is the absolute smallest value is -7, and it happens at x equals 2. So again, the absolute is stating the absolute highest point and the absolute lowest point on the original function. Okay, so these don't make a sign chart. Absolutes make tables. And then you plug them into the original. Let's try another one here. Go ahead and try C. Okay, so again, I need to find the derivative first. Nice little quotient rule. x squared plus 6x over x plus 3 squared sound? Low d high minus high d low over low squared. Thanks, Jill. Okay, now when we have a fraction, remember we set both the top and the bottom equal to 0. So I'm going to solve the top by factoring. Pull out a nice easy GCF, x and x plus 6. So I'm going to get x equals 0 and x equals negative 6. And then I'm going to set the bottom, because that is when the fraction is undefined. Square root both sides, and I get x equals negative 3. So again, quotient rule for my derivative, set the top and bottom equal when you have a fraction, and solve for x. Now we're going to go back to the table of values because this is an absolute. Start with your closed interval. It's going negative 2 to 1. Am I actually going to use all these pieces? Does 0 fall in that interval? 0 does. Does negative 6? So I'm going to get rid of negative 6. And how about negative 3? No. So the only one I really have to test out of all my solutions is the endpoints and 0. And again, they're going to go back to the original, so make sure you call that upper bound h of x, or upper part of your table. So I'm going to plug in a negative 2. Negative 2 squared is 4 over negative 2 plus 3 should get me a 4. 0 squared over 0 plus 3 should get me a 0. And that would get me a 1 over 4. And then again, we just want to make sure we answer the question. The absolute max, the highest this graph is going to reach, is 4, and it happens at x equals negative 2. The absolute min is 0, and it happens at x equals 0. All right, let me show you just one different one. If you flip the page. And maybe look at this picture here, number 4. It says the function is differentiable on the closed interval. The graph of g prime, the derivative is given. At which value of x does g have an absolute max? Okay, so the moment I see absolute max, again, I have to set the derivative equal to 0. I want g to have a max. I'm looking for when g prime equals 0. What are the values I'm going to consider? When does that graph equal 0? At 0, 4, and 6. Okay, so I have 0, 4, and 6, and my bounds go from 0 to 6. Now, here's the catch on the graph. I have to plug them back into g. Do I actually know anything about g? I don't really know anything. They don't even give me a starting value. I literally know nothing about g, so I'm going to have to talk myself through this one. From 0 to 6, if g prime is positive, what is the function doing? If g prime's positive, it's increasing, right? So I know between 0 and 6, I'm going to try to sketch out g. I know from 0 to 6, the function has to be increasing. I don't know how, but it's definitely going up. I keep saying 6. I mean 4. Sorry. 0 to 4. 0 to 4. From 4 to 6, what's the function doing? Decreasing. Now, here's what we're going to start to do in the next few weeks. Look at the amount it increases versus the amount it decreases. Which did it do more of? Definitely increased a lot more than it decreased. So all I know is it increased and decreased. I can only state that there has to be a what at 4? There has to be the absolute max has to be at 4. Do I know the value of it? No, and it doesn't ask that. It says at which x value does the graph have a max? I can only say it happens at 4. I don't know what it is, but I know it's happening at 4 because this function increased and then decreased. Okay. So our goal tonight is just page 211, just the absolutes. There's 8 of them. Just take your time. We're making the t charts, not the sign charts. Okay, so just page 211 there. And then we are going to go test next Friday. So we have Monday off. Enjoy your long weekend. And we'll go test next Friday. So we'll hit all that increasing, decreasing, max, min hard on that test. Have a great long weekend.